This is example 1 of lesson 3.3, which is solving addition equations. Remember, an equation is two expressions on either side of an equal sign. So an equation has an equal sign, expressions do not. We've been dealing with expressions, now we're dealing with equations. So I have a couple of addition problems here, and you'll notice they have variables in them. 23 plus m equals 39, and 9.4 equals y plus 5.1. We're going to learn how to solve these, and yes, I know you can look at these and solve them fairly easily. However, not the point. Again, we are practicing process, not necessarily the math itself. So in order to show you how this works, I'm going to take us over, not here, here, to this PhET simulator. And what I have here is a balance scale. It's a lovely balance scale. It's very nice. An equation is a balanced thing. One box, let's call him B. B plus 4 equals 7. Okay, B plus 4 equals 7 is basically what I have here. And what I'm doing here is trying to maintain the balance while also getting B by itself, because in order to find out how much B equals, we have to get rid of all the other junk that's cluttering up his side of the equation. So, B plus 4 equals 7. How am I going to get B by himself? By removing things from both sides. Equations are just like fractions. What I do to one side, I have to do exactly that same thing to the other. So you notice I took away 4 from both sides. I subtracted 4 from both sides, and now I'm left with just the box on one side and just 3 on the other. So in this case, B equals 3. When you're doing an equation, you need to maintain your balance. So if I'm going to take 4 from one side to get B by itself, I have to take 4 from the other side. So let's apply that to our other equations. Not this slide, this slide. There we go. Let's apply that over here. I have 23 plus m equals 39, and my goal is to get this 23 by itself. To do that, I need to get rid of this 23. I need to get rid of that 23. That 23 is being added to m, so in order to get rid of it, I need to do what's called the inverse operation. Inverse, you might remember from fractions, is the opposite. Inverse means opposite. The opposite, or inverse, of addition is subtraction. So what I'm going to do is I'm going to subtract 23 from both sides, because what I do to one side of the equation, I have to do to the other. And you'll notice how I'm writing this. I'm writing it right below like that, and then I'm going to put my equal sign here. I'm going to keep my equal sign sort of in a line, deep, 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 right there, underneath my other equal sign. The m stays the same. It doesn't change. M, bam. So I've got minus 23. 23 minus 23 is 0, so I've got 0 plus m over here. I'm not even going to write that. I don't need to. And then I have 39 minus 23 on this side. And 39 minus 23, 9 minus 3 is 6. And 3 minus 2 is 1. So m equals 16. And I can check that by plugging 16 back into my expression, just like we did in 3.1. 23 plus 16 equals 39. Is that true? Well, yes it is, because 6 plus 3 is 9, and 1 plus 2 is 3. So we have our solution, m equals 16. Let's do this one over here. Oh no! The equation's backwards. It doesn't matter. It's still a balance scale, guys. It's still a balance scale. 9.4 is still equal to 5.1 plus y. It doesn't matter which side of the equation it's on. I want to get y by itself. That's my goal. Make y as lonely as I possibly can make it. In order to do that, I need to get rid of this 5.1. How am I going to get rid of the 5.1? By doing the inverse operation. It's being added, so I'm going to subtract 0.1 minus 5.1, because what I do to one side of the equation, I have to do to the other. So I end up with y equals, because the y hasn't changed, line up my decimal, subtract 4.4, 4 minus 1 is 3. 9 minus 5 is 4. Decimal falls down right there. So 4.3 equals y. And I can check this. Check to make sure. 9.4 equals 4.3 plus 5.1. Is this a true statement? 3 plus 1 is 4. 5 plus 4 is 9. Yes. That is a true statement. I have my solution to my equation. Inverse operation to solve. You want to undo addition, do subtraction. Make sure you do it to both sides, though. Keep things balanced.